Awesome. Thanks for hanging around to the last session. I feel like this is no pressure because there's only a few of us left, and most people are, off in a better place in their mind anyway. So like Homer said, my name's Carl. I'm the CTO at a company called Grade Network. We basically hook K through 12 teachers up with college students who grade papers for them. I hate to be the Uber of something, but kind of the Uber of paper grading, if you have to go there. If you want to talk about ed tech, I love talking about that. We can talk about that later. But today, what we're going to talk about is testing distributed systems. I imagine that most of you here are working in some level of distributed system because basically all that means is that we've got multiple servers, computers out there in the world distributing data through, in our case, APIs a lot of the time. Leslie Lamport's a really smart researcher who does a lot of work in distributed systems, and this little quote is funny because basically he just calls distributed systems one in which a failure of a computer you didn't know existed causes your own computer to become useless. I love that because that's like an example of a bad distributed system, but it's also just kind of what we deal with on a daily basis. And so that's why we write tests for this stuff. But I think it's only part of the reason. So first of all, we do want our applications to be fault tolerant. So we write tests to help prevent things from falling over when one API in our multi-API system has a problem. But we also have to think about the fact that we can't control every API or service that we rely on. So for example, most of the applications I build these days use at least 2 or 3 third-party APIs, and I can't control whether or not those third-party APIs use semantic versioning correctly, or they're going to tell me when they make updates. The same is true if you work in a larger organization and you rely on internal APIs from other divisions in the company. You may or may not get the message when something changes and breaks, and a lot of the talks in this testing track have kind of been on this same vein. Network connections are not perfect, and while they're pretty good when we're talking server to server within the same data center, maybe for that kind of case we can just deal with a retry. When we're talking about going to clients and mobile applications across any kind of internet, it's super hard to tell what's going to work and what won't. We're using more and more imported packages in distributed systems, and a lot of that's because we write API clients that we share between all of our different applications, whether we maintain them internally or we rely on ones from third parties. And we also have started to build this idea of microservices, and smaller service-oriented architectures has started to build these siloed teams that are in charge of maintaining one single service or maybe just a group of services that encapsulates a certain domain. So I think testing is really important there because while you can document your API and that's great, another level of being able to trade information is having good test coverage. That's kind of like my favorite supplement to documentation is testing. So in this talk, we're going to go through 3 things. We're going to do a quick intro to what the layers are that I've used with teams when testing a distributed system. And a lot of that, the point of that is to get on the same page when it comes to terminology. And then we're going to go through how we would use them in testing a traditional monolith. And then quickly we'll get into how we would create a real test plan with a real distributed architecture. And since this is the last session of the day, we'll have plenty of time for questions because I'll just hang out. So if you don't get to ask it in the time limit, that's all right. So Martin Fowler actually introduced me to this idea, and the 2 people from ThoughtWorks just left. Sad. So he writes a lot for ThoughtWorks, or did. I don't know if he works there anymore. But he has a great presentation on testing in microservices, and so I borrowed some of his ideas about the layers of tests from that. So if you want, you can look that talk up. So the first layer, unit tests. How many of you write unit tests on a daily or weekly basis? I hope everybody does. That's great. That's good. First level, and I think these are really important. They're kind of the base of the testing pyramid, if you're familiar with that model. And basically what we do in a unit test is we mock any dependencies. We inject mocks where we can. We don't make real calls to things like databases and file systems. Instead, we use some sort of fake data there. And it's really cheap to cover a lot of different cases with unit tests, but they're not super comprehensive, and I don't think they're nearly enough, especially for larger distributed systems. And having been through this testing track, I think we've heard a lot of great examples of what you can do to supplement unit tests, and that's what we're going to kind of talk about. The next layer up is integration tests. And so I define an integration test as a test that covers a working group of code components, whether those are 2 or 3 classes that work together, or they are the interface over a service layer, so it's making HTTP calls, and we'll get into some examples of exactly how that works. I think they're also really good for tightly coupled legacy code that's not tested. So I've come into a couple organizations that had really low-cost MVPs built that had zero testing. And a lot of times the first thing I did was start writing integration tests where I could at least test a big chunk of code together and then start breaking it up and refactoring. The next layer up are acceptance tests. And acceptance tests, a lot of people use this term interchangeably with end-to-end tests, but I'm going to use them differently because I think they are different things when we're talking about distributed systems. An acceptance test validates at the service level. So when we have microservices or service-oriented architecture, we have a bunch of APIs. Each of those needs to be validated as well as the end-to-end test across the whole system of multiple APIs and front ends and what have you. So these validate at the service level. I like to, when I write my acceptance test, if possible, mock any of the dependent services that they have. Some people do, some people don't. Sort of depends on what you're trying to accomplish with your testing goals there. And then the final layer are end-to-end tests, and these are the most expensive. They take the longest to run. A lot of the talks here have talked about how they're challenging to work with, and I would totally agree. But they're also very useful for seeing the whole application come together. Some organizations I know are still doing a lot of end-to-end tests manually, where you've got a team of QA people who click test through an application. And that's certainly fine if you're there. If you can get these automated, there's some great tools that you can use to do that. We can kind of talk about that after as well. But I think that getting these automated and getting them part of your test and continuous integration suite is really important. I also like to, when doing end-to-end tests, use real application data from third-party APIs. And that can be tough because sometimes they charge you for that data. If that's the case, maybe I try to find a sandbox. If they don't have that, then maybe we mock it as sort of a last resort. So these are our 4 layers. And we're going to use these 4 layers to set up some sort of example test plans for applications in the real world. And we'll start off with something real simple. How many people have set up an MVC application? Model View Controller, the classic Web 101. Like you start Rails, right, and you get your MVC architecture. Still super useful, but at the same time, not very realistic. So we don't write a lot of applications that are this small or this sort of simple in their layers. But let's look at how we would test that anyway. So I would start off with unit tests around anywhere that has a good chunk of business logic. So that's the model, the controller, maybe the router, depending on how your framework is set up. Everyone does it a little differently. And then I would have an integration test between the model and the database. So models are typically going to interact with the database through an ORM, at least in a sort of model view controller method. So maybe that's active record or something else. But I find it really helpful because unit tests on a model can be tough. I find it really helpful to do an integration test instead, because what we're doing there is seeing that when we actually spin up this model and we ask for data, that we're getting the data we actually think we should. So that's a case where integration tests can be a good supplement to unit tests. An acceptance test around this would basically mock data from the database. So it would you would mock something in there, you'd inject something in there to get, you don't actually have to spin up a whole database for those acceptance tests. And then an end-to-end test would actually spin up the data in the database. So once again, this is really simple and kind of watered down to like the most rudimentary elements. So the difference between acceptance and end-to-end tests in this case is pretty small. But we'll see that in the real world, things aren't that simple, and the difference starts to get more concrete once we've got multiple services across many different HTTP layers. And in the real world, we get to deal with a lot of new problems. So the first one being we've got multiple Git repositories, a bunch of servers, or maybe a bunch of servers with a bunch of containers on them. We've got shared packages that we're maintaining or importing from third parties. We've got APIs we rely on that are ours internally, but also APIs that are not ours. We build things through multiple continuous integration pipelines. We've got different front-end build processes. And I'm not going to cover how testing solves all, like how it can verify all these things are working. But I think these things need to be part of our test plans. When we're thinking about how we actually put together making sure our application works as a whole, it's important to think that the application is not just the code we actually wrote. The application involves lots of external pieces that we may or may not have direct control over. So let's jump into a little architecture diagram for a slice of a distributed system. So in this one, we've got I'll see if I can pull this out here. We've got a front-end application that connects to 2 back-end microservices or REST APIs of some kind. Each of those imports some kind of internal package and maybe an open source package. And then we've got each of those microservices connecting to a database and then a third-party API. So we'll kind of get some more specific in a second as to what those might look like. But so far, is this kind of resonating? Do people work with applications that look something like this, but maybe at a bigger scale? I do. Okay, cool. So let's make a plan for this. And the first, I've got a few steps that I would typically take, and these don't get very specific, and you're welcome to sort of take these and branch off them and figure out your own steps that make more sense for you and your team. I like to first isolate a pathway of data. So worry about one pathway at a time and not think about, this whole application is one big messy thing, but think about it as how do I get users out of the database and bring them to the front end? That's one pathway of data. Then I would break each service that data touches along the way into different layers that are contained within it. We'll see what that looks like in just a second. And then for each service that I'm kind of evaluating, I'm going to look at how I'm going to test the internal functionality with things like unit tests, and how I'm going to test that it interacts correctly with things like third-party APIs or other services that we maintain internally. So lots of words. Let's do this in practice. Let's say that we're building an application that has users in it, because almost every application has users, so it's a great example. So in this case, I want to get users from my database through a backend microservice, present them on the front end. But the little gotcha that makes this more fun is that I also integrate in some data from a third-party API. So maybe I pull in some Facebook data while I'm grabbing users. Pretty common kind of thing. I've also written an internal package that helps me grab that data from that third-party API. So it's just maybe an HTTP client with a few little data transport methods or something like that to keep the data clean. So I isolated my pathway of data, and I'm going to put it in kind of a linear silo so I can see how everything flows together. And then the next thing I'm going to do is break it up into the core components, the core services that we are concerned with testing. So we've got a shared package. I typically don't run tests on the database itself because I'm using pretty reliable open source databases like Postgres and MySQL. And if those have problems, then there's bigger things in the world that are going on. So typically I won't do that, and it's hard to test, obviously, the third-party service on its own, although we will integration test how it works with our services, because that's what we really care about. The back-end application and the front-end application are the pretty obvious places where testing comes in. So we've broken this thing into layers. Let's look at each layer individually and then talk about the sort of layers of tests that we would have within it. So much like we did with the monolith, we're basically looking at these services, individual services or packages, and we're trying to break them down into what are the levels of tests that we want to write for this thing. So the first level is a unit test. So this internal package, once again, it's just going to connect to a third-party API, pull in some data, do some transport or munging of it, and then give us out a nice interface to use in our backend application. And so I want to unit test that, obviously. I want to mock that I can make that connection and that the data comes through. And then I want to also do an integration test that actually calls that third-party API. What's useful about this for me is I'll run that on like an hourly basis. So I know if that third-party API changes at some point on, I'll have at least like 1 hour where I knew that third party made a breaking change and broke my API client. If your sort of like SLA expectation is much higher, you may want to run that more frequently, or you may want to deal with some kind of like, more reputable third parties that don't have breaking changes to their APIs all the time. But we don't always get to control that, right? So I'll run those integration tests as often as I can. The other thing to keep in mind is that sometimes we just can't do all the integration tests. So let's say it involves creating a resource on a third-party service and they don't have a sandbox. We may have to just skip that one or mock it or do something to work around it. But running those real integration tests with an actual API is important and really helpful. The other thing I'll say here when thinking about writing these unit tests for HTTP clients especially, or any client that interfaces with another application, is to think about writing the unhappy cases. And so what I mean by that is write the failures. So what happens when that third-party service throws a 400 error? What happens when it throws a 500 error? Are our unit tests covering that, and are they giving us the right thing when it goes all the way through the system? The next layer up is the backend application, so backend microservice. For this, I'm going to, once again, just like I did with the MVC Monolith, I'm going to integration test the model to database relationship, because I think that's the handiest way to do that. And then I'm going to integration test that the either model or controller, whichever one's connecting to that internal package that we've built, make sure that that actually works. This integration test can go one of two ways. You can either have it just test that the internal package works with our model or control with our code here, or you can have it go all the way through to the third-party API, which isn't sort of pictured here, but you'd picture that as the next level up. And that sort of depends on how easy or hard that test is to write and to maintain. Unit test my controllers and routers once again, and then acceptance test the whole backend microservice while mocking the database and third-party connections. Because once again, the goal of that acceptance test is just to get this one service working in a predictable way. The front end is much the same as the back end, except this time we're sort of testing in our integration tests the HTTP client to the back-end microservice and how those will work in tandem. And ideally, we're testing with a real instance of our back-end microservice so that we can get real data through, whether that's setting up a test environment or having multiple containers that run during the test, whatever your solution for that is. And then unit testing each layer in the front-end application, acceptance testing the whole thing. And then the sort of last one here, it's a lot of words, so I apologize for that. But my point here is just to kind of show you how it all fits together. And writing this kind of test architecture out it looks maybe a little idealistic, and I think it is. I think this is sort of like we start with this as a target, and then the real world happens, and we break things down as is really possible and realistic. The last thing that I kind of, sort of right-clicked there, didn't I? The last thing that I didn't mention here is that we also add a layer of end-to-end tests. So for that, those end-to-end tests can run either every time any of the services are updated individually. They can run on an hourly or daily basis, or you can have them run once a week. Just depends on the size of your system and the sort of requirement of having those and how robust they need to be. Cool, so let's just do a quick review and see what we learned here. The first is unit tests are great for internal testing within services and applications. So start there. It's the base of the testing pyramid for a reason. There's a lot of them. You can cover a lot of business logic, a lot of finer points that way. But they don't do a great job testing what things like integration tests do, which is the connection between services, which in distributed architecture becomes one of the really challenging and I think important things to think about. So integration tests in sort of my vocabulary, tend to test between the services and the databases, services and their connection to each other. And then acceptance tests are going to test individual services as a whole without the connections to third-party services. So they're kind of like a mini end-to-end test. And then the very last layer are end-to-end tests that cover the whole application where we set everything up at once and get it running. So thank you guys so much for your time, for sticking with us to the very last session. This is very exciting. This is my first time giving technical talks a technical talk at a conference, so I would love feedback. My Twitter, GitHub, everything is Carl L. Hughes. If you've got anything to say, just spit it out. And I'll just end it with, does anyone have any questions on this or anything else with testing? Cool. Thank you.